Hello everyone. In this question, we are given that there is an LR circuit shown in the figure in which if the switch S is closed at t equals to 0, then the amount of charge passes through the battery between t is equals to 0 to t equals to L by R is equals to. So we have to find the amount of charge which passes through the battery between this time. So firstly we have a formula for current as I is equals to I max into 1 minus e power minus RT by L, where I max is equals to E by R, the EMF of battery upon resistor. So we use this formula for, then we can write I as dq upon dt is equals to I max is equals to E by R 1 minus e power minus RT by L. So dq is equals to E by R 1 minus e power minus RT by L dt. So we integrate on both sides. After integration, for dq is equals to integration E by R 1 minus e power minus RT by L dt. So we put the limits for q as 0 to q, how much charge is flown. So we have to find the limit for q, and time we have given in the question 0 to L by R. So after integration, here q is equals to E by R, here t plus L by R e power minus RT by L. So we put the limits here from 0 to L by R. So q is equals to E by R plus L by R minus 0 plus L by R e power minus 1 minus L by R e power 0. So this cancels this. So q is equals to E by R into L upon ER. So q is equals to EL by 2.7 R square. So this is our answer for the charge flown in the circuit. So our option A is correct. Thank you.
क्वेश्चन क्या है अपना, एक कोयल ऑफ सेल्फ इंडक्टेंस 10 माइक्रो हेनरी एंड रेजिस्टेंस 0.1 ओम is connected through a switch to a battery of internal resistance 0.9 ohm. After the switch is closed, the time taken for the current to 80% of the saturation value. ठीक है, saturation value अगर मैं I नोट मानूं तो किसी भी टाइम t पे जो मेरा करंट होगा I is equals to I नोट 1 माइनस e की पावर माइनस, ये मेरा करंट होगा, है ना। अब इसका 80% जो आई है वो मेरा 80% हो, कब होगा, तो उसके करस्पॉन्डिंग पर वो टाइम पूछा है बेसिकली। और अपन को जो एल गिवन है वो 10 माइक्रो हेनरी है, और यू कैन से 10 रेज टू पावर माइनस 2 हेनरी। और जो रेजिस्टेंस है अपना, वो जो अपना कोयल का रेजिस्टेंस वो 0.1 है, और जिस बैटरी से कनेक्टेड उसका रेजिस्टेंस 0.9 है। दोनों सीरीज में, इसलिए मैं इनको सिंपली ऐड कर सकती हूँ आर इक्विवेलेंट कैलकुलेट करने के लिए। तो दिस इज बेसिकली 1 ओम। ठीक है। तो अब अपन इसको वैल्यू रखें तो 80% मतलब 0.8 टाइम्स ऑफ आई नोट इज इक्वल्स टू आई नोट 1 माइनस ई की पावर, मुझे टाइम बताना है, आर का वैल्यू मेरे को गिवन है दैट इज 1 बाई 10 रेज टू पावर -2। ठीक है, आई नोट से आई नोट कैंसिल, 0.8 इज इक्वल्स टू 1 माइनस ई रेज टू पावर 10 रेज टू पावर माइनस ऊपर जाएगा 2, ऊपर जाएगा तो यहाँ पे ये टी। अब ई को इधर ट्रांसफर कर देते हैं, इज इक्वल्स टू 1 माइनस 0.8 दिस इज 0.2। अब जैसे ये है ई की पावर -10 to the power 2t इज इक्वल्स टू 2/10। अब इसको इधर भेज देते हैं, 10/2 इज इक्वल्स टू, मतलब मान लो रेसिप्रोकल कर लिया बेसिकली मैंने। ठीक है, तो ये आ जाएगा -10 रेज टू पावर 2t, तो 5। और अगर ये ऊपर लिखूं मैं, अब दोनों तरफ मैं ln ले लूं अगर, तो बेसिकली ln 5 इज इक्वल्स टू ln। ठीक है, अब ये पावर जो ये मेरा बाहर आ जाएगा, ये अपनी प्रॉपर्टी से पता है अपन को, और इसकी वैल्यू 1.6। अब देखो प्रॉपर्टी अपना क्या है, प्रॉपर्टी मेरा ये है कि जैसे ln e की पावर c इज इक्वल्स टू c ओनली। ठीक है, ये प्रॉपर्टी वैसे डिराइव होता है कि भाई log b a c, तो यहाँ पे आता है c log b a, और यहाँ पे b और b की वैल्यू सेम है तो उसकी वैल्यू 1 हो जाएगी। तो ln के केस में क्या होता है, log e बेस e तो होता है, इसलिए अपन ये इसको जनरलाइज बोल सकते हैं ऐसे वाला। ठीक है, तो ये मेरा हो गया कि 1.6 बाई 10 to the power 2 सेकेंड इज इक्वल्स टू टी। ठीक है, या फिर उसको आप बोल सकते हो 0.016 सेकेंड। तो अपन को बेसिकली इतना टाइम लगेगा, 0.01 सेकेंड। ऑप्शन ए इज करेक्ट। ओके, थैंक यू स्टूडेंट्स।
Hello students, this question is from LR circuit, that is the DC current when applied to a LR circuit. So the question is, a 20 Henry inductor coil is connected to a 10 ohm resistance in series as shown in the figure. Okay, time at which rate of dissipation of energy across resistance is equal to the rate at which magnetic energy is stored in the inductor is. Okay, so let's start. Before we proceed, we know that current in an LR circuit is given as current in LR circuit is given as is I equal to I naught into 1 minus e to the power minus t by tau. Okay, where I naught is e upon r and t naught tau is L upon r. Okay, so let's start. Since it is given that magnetic energy stored is equal to rate of dissipation of energy in resistors. Okay, so rate of energy dissipation in dissipation across resistor will be is equal to I square R. Okay, similarly rate of energy stored in inductor will be I L di by dt. So according to the question, we have to equate these equations and we have to find the time at which both are equal. Okay, so we will be doing I square R is equal to I into L di by dt. From here, I and I one of the I from the I square gets cancelled out. So this equation becomes IR is equal to L into di by dt. Okay, now here we will calculate di upon dt, which is equal to I naught into minus of e to the power minus t by tau into minus of 1 upon tau. So this minus minus will get cancels out, and again it will be equal to I naught into e to the power minus t by tau into 1 upon tau. Okay, so again equating this, we will get as, now what we will be writing here it is IR, so I can be written as I naught into 1 minus e to the power minus t by tau into R is equal to, from here, L di by dt, L into di by dt. And what is di by dt? It is I naught into e to the power minus t by tau into 1 upon tau. Okay, continuing further, what we will be getting here, it is I naught and I naught gets cancelled out simply, so the equation will be 1 minus e to the power minus t by tau into R is equal to L naught into e to the power minus t by tau, and as we already mentioned that tau is L by R, so 1 upon tau will be R upon L. So this L and this L gets cancelled out, this R and this R gets cancelled out, so the equation becomes 1 minus e to the power minus t by tau is equal to e to the power minus t by tau. Fine. So again what we will be getting here, again it's simple, 1 is equal to 2 into e to the power minus t by tau. Now what we will be doing here, taking ln both sides. Okay, so what will be the equation here? It will be ln of 1 upon 2 is equal to minus t by tau, which can be further written as minus ln 2 is equal to minus t by tau. Minus and minus gets cancelled out. Again what we'll be doing here, ln 2 is equal to t by tau, and once again 1 by tau is nothing but it's simply, as we know that tau is equal to L by R, so 1 upon tau will be R upon L, and t is equal to L by R ln 2, and putting the values of L and R, we will get as t equal to 2 ln 2. So this is the required answer for which we were looking for. Okay, so the answer is t equal to 2 ln 2. Thank you.
Hello everyone, a series AC circuit containing an inductor of 20 millihenry and a capacitor of 120 microfarad and a resistor of 60 ohm is driven by a AC source of 24 volt and 50 Hz frequency. The energy dissipated in the circuit in 60 seconds. So if you see here, the frequency is given, you can get the omega. So I will write down the omega is equals to, so it is 100 pi. So as you got this, you can get the XL and XC. So if I write down the XC, it will be 1 upon And XL I will write down, it is omega L. So it is L is 20 millihenry. So I will multiply here 10 to the power minus this. So if you see, these three zeros will get cancelled out and it will be 2 pi only. And if you see this, it is, if these 30 here, it will get cancelled out, and here you will get 1000 by 12 pi. So it will be equals to, and here you will write down, it is this. So if you see, you can get the Z value now. So I will write down the Z is equals to under root of R square plus XC minus XL whole square. So if you see here, it is R is 20. It is already given in the question. Here if you see, the resistance is 60. So I will write down the resistance 60. XL minus XC, it is minus whole square. So after solving, if you see, it is nearly equals to 20, right? So it will be equals to under root of 10 and this. So as you got this, you can get the cos phi value, the power factor. It will be equals to R by Z, that is 60 by this. So it will be 3 root 10. So after getting this, we can get the power, right? So I will write down the average power. It will be equals to cos phi. So you can just put the value, so it will be equals to V square by Z cos phi. So from here you can just see that the V is already given. So this is the V RMS, right? So it will be 24 square by Z is this. So you can just solve it. It will be equals to, and here the cos phi you will also write down. Cos phi is this. Z is this. So from here you will get this. It is equals to this. Now we want the energy dissipated in 60 seconds. So it will be simply to time. So it is this much. And this will be the answer of this question. I can just check for the option here. C is the correct. Thank you.
Hello everyone, let's start the question. Question says that in the figure shown, a circuit contains two identical resistors with resistance R equal to, it should be 5 ohm, okay, and an inductance with L equal to 2 Henry. An identical battery of 15 volt is connected in this circuit that will be current through. So what will be the current through the battery long after the switch is closed? So we have to find out the current when this switch will be closed and after long time. So after long time we have to find out the current. Okay, so before solving this question we should know the behavior of this inductor. Okay, so if we close the switch, okay, closed the switch, okay, for long time, let's say infinity, then this the inductor behave like zero resistance. Okay, so we can assume that after that we can assume that here we can assume the inductance like a wire. Okay, so here zero resistance. So If we remove the inductance over here and assume that it is only a wire, then R and R both will be in parallel combination. Okay, math in parallel connections, okay, with the battery. So here R equivalent will be, R into R divided by 2R, or we can say R by 2. So now this is a simple formula based question. We can write the current equal to V by R, and voltage is given in the question. It is 15 volt. So if we put the value 15 and the R is R by 2, so the 2 will go up. Okay, now if we substitute the value, so we can write here 15 into 2 divided by 5. The value of R is 5 ohm. Now we can solve here, so it will be 3, and we can write 3 into 2, that is 6 ampere. So if we check the options, the correct option is 6 ampere. So we can write correct answer is 6 ampere. Thank you.
Hello everyone, so our question is, an inductor whose inductance L is 0.03 Henry and a resistor whose resistance is 0.15 kilo ohms are connected in a series to a battery of 15 volt EMF in a circuit as shown below. The key K1 has been kept closed for a long time. Then at t is equals to 0, the key K1 is open and key K2 is closed simultaneously. At t is equals to 1 millisecond, the current in the circuit will be, we have to use the data e raised power 5 is equals to 150. Okay, so in the given figure we have been given an LR circuit. Okay, now the key K1, this key K1 is kept closed for a long time. So the inductor will behave as a zero resistance after a long time when the key K1 is closed. So the current in the LR circuit will be, I0 will be given as V by R. V is 15 volt and resistance is 0.15 kilo ohms. So I0 will come out as 0.1 ampere. Okay, now what we are doing, that at t is equals to 0, we are opening the key K1 open and K2 is closed. Okay, now key K2 is closed simultaneously. Now what will happen is the inductor will behave as a source and the current will start decaying, and the decay in the current is given by the expression I is equals to I0 e raised to the power minus RT upon L. Correct. Now substitute the respective values. So I will be, I0 is 0.1 e raised to the power minus R. R is the resistance, given to us is 0.15 kilo ohms or 0.15 into 10 raised power 3 ohms into time is 1 millisecond or 10 raised power minus 3 seconds divided by the inductance, that is 0.03 Henry. So on solving this we will get I as 0.1 e raised to the power minus 5 or 0.1 into 0.1 divided by e raised power 5. Now the value of e raised power 5 is given to us as 150. Correct. So from here our current comes out to be 0.67 milliampere. Okay, now looking at the options, we get option number 3 is the correct option, that is 0.67 milliamperes. Okay, thank you.
Hello everyone. Question is, in an LCR circuit as shown below, both the switches are open initially. Now the switch S1 is closed, S2 kept open, Q is the charge on the capacitor, and tau is equal to RC is the capacitive time constant. Which of the following statement is correct? Okay, तो यहाँ पे देखो एक LCR सर्किट है, जैसा कि यहाँ फिगर में दिखा रखा है. both the switch are open initially. Okay, then now the switch S1 is closed. Okay, अब क्या कर देते हैं, S1 को close कर देते हैं and tau is equal to RC जो कि कैपेसिटिव टाइम कांस्टेंट है. विच ऑफ द फॉलोइंग स्टेटमेंट इज करेक्ट. तो यहाँ से हमें बताना है कि कौन सा स्टेटमेंट करेक्ट होगा। ओके, तो यहाँ पे देखो क्या है कि स्टार्टिंग में दोनों स्विच क्या है, ओपन है। ओके, फिर क्या कर देते हैं, नाउ द स्विच S1 इज क्लोज। ओके, ये जो स्विच S1 है इसको हम क्या कर देते हैं, क्लोज कर देते हैं। ओके, तो यहाँ पे देखो क्या होगा, ये जो कैपेसिटर है, ओके, तो यहाँ पे देखो Q इज इक्वल टू क्या हो जाएगा, एलसीआर सर्किट में हो जाएगा Q नॉट 1 माइनस ई की पावर माइनस का टी बाई टो। ओके, सो Q इज इक्वल टू यहाँ से कितना हो जाएगा, हो जाएगा Q नॉट CV के इक्वल, और ये हो जाएगा 1 माइनस ई की पावर माइनस टी बाई टो। ओके, और टो इज इक्वल टू यहाँ पे किसके इक्वल है, RC के इक्वल है। ओके, जो कि हमारा क्या है, कैपेसिटिव टाइम कांस्टेंट है। क्या है, कैपेसिटिव टाइम कांस्टेंट। ओके, सो अब यहाँ पे देखो हमें बताना है कि इनमें से कौन सा ऑप्शन मेरा करेक्ट होगा। ओके, तो यहाँ पे देखो Q इक्वल टू क्या आया यहाँ पे एलसीआर सर्किट में, CV 1 माइनस ई की पावर माइनस टी बाई टो। ओके, ये इक्वेशन फर्स्ट हो गया। अब देखो उसने बोला कि वर्क डन बाय द बैटरी इज हाफ ऑफ द एनर्जी डिसिपेटेड इन द रेजिस्टर, तो ये तो हो ही नहीं सकता। ओके, क्योंकि वर्क डन बाय द कैपेसिटर जो होता है वो हाफ CV स्क्वायर के इक्वल होता है, मतलब कि एनर्जी वहां पे जो होती है। ओके, अब देखो एट T इज इक्वल टू, अगर यहाँ पे मैं टॉ पुट करता हूँ तो यहाँ पे देखो Q कितना आता है, वो आ जाएगा CV और 1 माइनस ई की पावर, ये आ जाएगा माइनस का T की जगह टॉ रखेंगे तो टॉ बाई टॉ, टॉ से टाउ कैंसिल आउट हो जाएगा यहाँ पे। सो Q इज इक्वल टू यहाँ से कितना आ जाएगा, CV और 1 माइनस का ई की पावर माइनस का 1। ओके, तो T इज इक्वल टू टॉ पे देखो ई की पावर माइनस 1 आ रहा है। ओके, तो ये ऑप्शन भी मेरा रॉन्ग हो गया। पुट करते हैं हम क्या, 2 टाउ। ओके, तो यहाँ से देखो Q इज इक्वल टू कितना आ जाएगा, CV और 1 माइनस का ई की पावर माइनस टी की जगह टॉ, 2 टॉ अपॉन में टॉ, टॉ से टॉ कैंसिल आउट हो गया। तो Q इज इक्वल टू यहाँ से देखो कितना आ गया, CV 1 माइनस का ई की पावर माइनस का 2। ओके, तो यहाँ पे देखो जब हम इसमें क्या रख रहे हैं, T इज इक्वल टू 2 टॉ रख रहे हैं, Q इज इक्वल टू Q नॉट 1 माइनस ई की पावर टी बाई टॉ में, तो यहाँ पे देखो ये आता है Q इज इक्वल टू CV 1 माइनस ई की पावर माइनस 2। तो यहाँ पे देखो ये ऑप्शन क्या हो जाता है, मेरा करेक्ट हो जाता है। ओके, T इज इक्वल टू टॉ पे देखो CV 1 माइनस ई की पावर माइनस 1, ये तो नहीं आ रहा, तो ये भी रॉन्ग हो गया। तो यहाँ पे हमें बताना था कि कौन सा स्टेटमेंट मेरा करेक्ट होगा। तो यहाँ पे मेरा C ऑप्शन विल बी करेक्ट फॉर दिस क्वेश्चन। आई होप यू लाइक दिस वीडियो एंड थैंक्स फॉर वॉचिंग।